Hello class, welcome to the online classroom. Today we are going to go over the last part of lesson 1 where we're talking about how to solve a quadratic equation by graphing. So this is what you do when you get a trinomial or quadratic that you cannot factor. So you graph it either manually or by technology. Now normally if it's a quadratic you cannot factor, you are generally not going to do it manually anyway. So it's usually for graphing with technology. So we've already kind of touched on this in the last video. You should also be able to be given a graph of a quadratic and be able to find the solutions on the graph already given the graph. So that's what we're going to talk about today. So I am going to share these notes and we're going to continue on with this. Now, I actually just did this entire lesson and then realized that I stopped recording or sharing the screen for a crucial moment of it, and I'm doing this for the second time. So hopefully I don't forget all those nice little extra learning tidbits that I throw into there. So back in the day, when you were just new students, fresh with learning, you learn that this is an equation, and you learn that it was, this particular one is slope-intercept form of a linear line equation, but that's an equation. And then your Math 10 very cruelly threw this at you and said, hey, this is function notation. And this might be a little new to some of you still, and you might not quite have got it. But what I love about function notation is it just kind of epitomizes that efficiency that we math people have. We don't want to say, hey, calculate the value of this equation if x equals 2. Way too many words, guys. We just say f of 2. Have at her. All right, so this is function notation right here that says all of what I just said. It said, hey, calculate this when x is equal to 2. So you substitute the value of 2 in for x, right? And if that f of 2 is really creeping you out, like it's just really throwing you, this whole thing is just replaced with a y. So if it really bothers you, just replace the whole thing with a y and calculate it as you would have done prior. Because it's basically the same thing. It's just saying, hey, y equals 2. No, sorry, it's saying we don't know what y equals, sorry. And it's saying, but we know x equals 2. So if x equals 2, what does y equal? And that's all we're trying to do, is we're trying to solve for what that equals. So keeping it in function notation, I just leave this as f of 2. It's not f times 2. There's not a second variable there. It's the function of, it's a function, and we're trying to find the value of the function when x equals 2. So then we do the work on the right-hand side. So f 5 times 2 is 10. We add 2, so we find f of 2, or the value of the function when x equals 2, is equal to 12. Okay, so that's function notation. The other function notation here is you have f of x equals 0. So that's saying the whole thing equals 0. So this whole thing here, f of x equals 0. F of x also equals 5x plus 2. That means that using transitive property, 0 must also equal 5x plus 2. So this is the same thing as saying, hey, y equals 0, find what x equals, back in the old days. Okay, so here's where you have to use a little algebra. You're going to subtract 2 from both sides. You're going to get negative 2 equals 5x. You're going to divide both sides by 5, and you're going to get x equals negative 2/5. So you could actually rewrite this statement that f of negative 2/5 equals 0. So you found this value of x that will make that statement true. So to summarize, you have function notation, so that would be f of x. And if we were doing quadratic function, f of x would equal something like 5x squared plus 3x minus 14. And if you wanted to find the x-intercepts, we would call these zeros. And we would call these zeros because we would be placing f of x to equal 0, just like we did up here, okay? So we are setting a value for y, and we are then solving for x. But there's actual multiple values of that exist on this function. So you could put any value in for y so long as it's above the minimum or below the maximum, and you will get a value or two for x, because it's not just the 1 point or the 2 points, it's all the points that exist on this parabola. So when you're finding the x-intercepts, you are specifically putting in a value for the function. The other, what we're going to be working on mostly here is actually the equation. So instead of it being a function of x, it's going to be equal to 0. Okay. The x-intercepts are actually the roots. They are the solution. Because this is an equation, we haven't set something equal to 0. It is equal to 0. We are trying to find the values of x that will make it true. And even though if we were to graph it, it would make a parabola, there's only those 2 points that are the solution to this equation. So that's why they get a slightly different name, as called roots. But to be honest, what you do to find roots and zeros when we're dealing with quadratics, whether we're dealing with functions or equations, pretty much the same thing. So you're not really going to have to adjust what you do. Just be aware that there is a difference technically with what we're calling them, and that difference doesn't really matter right now. But one day it might. Depends on where you go with your life. All right, so here we go. We have something written on the page. To solve an equation by graphing, determine the equation, what equation will equal 0, graph the parabola, and find the x-intercepts. This is because x squared minus 5x plus 6 equals 0. So you can actually graph it as a function. So you can say, hey, I'm going to graph this as if it was a function. But you're still setting f of x to be equal to 0. So you can use, even though we're going to graph a parabola, and it's going to look like there's all these points that exist on the line, we don't really care about all those other points. We just care about the x-intercepts, because those are going to be the roots or our solution. So if we were to wanting to solve this equation, there's actually multiple ways to solve it. We can solve it by factoring, we can solve it by graphing, we can solve it by completing the square and then solving, and we can solve it by something called a quadratic formula. So right now we're going to focus on just solving it by graphing. And to be honest, with this particular quadratic equation, I wouldn't solve this one by graphing, because you can factor it. You can just solve it with algebra, and you would get that x minus 3 and x minus 2 equals 0. You would just factor that trinomial. And then there's 2 instances where you can get this to equal 0. So you can have x minus 3 equals to 0. You would add 3 to both sides, and you would get x equals 3. So that would be right here. You can have x minus 2 equals 0. So you can add 2 to both sides. And the other value that will make this expression true is x equals 2. You can verify your answer algebraically by putting in the value of 2 for both these x's and making sure that it equals 0. So 2 squared is 4. Minus 5 times 2 is 10. So 4 minus 10 is negative 6. Negative 6 plus 6 is 0. So it works for this one. And then you can do the same thing for 3. So you can do 3 squared, which is 9, minus 15 is negative 6. Negative 6 plus 6 is 0. So that was solving by algebra. I didn't actually solve by graphing. So to solve by graphing, you would either have to make a table of values and plot it out as best you can and estimate, or you can solve by Xavier method. And this is to solve by graphing manually. So to solve by graphing manually, table of values is very time consuming and tedious. We would do it by Xavier method, but if we were just asked to find the roots, it's kind of, our work is kind of made redundant, because the first part of Xavier method is to find the x-intercepts, which is what we just did. Okay, so to do Xavier method, the first step, we went over Xavier method in a previous video, is to find your x-intercepts. So you don't actually have to graph it if you can do this step. The next step, it's just to remind you, is the axis symmetry. So you would take 2, you would add it with 3, you would divide by 2, because these are your 2 x-intercepts. You add them together, divide by 2, you get 2.5. So your axis of symmetry is down between the 2. And then the last step, I'm going to highlight my steps here. The last step is to find your vertex, which is to substitute your axis of symmetry value into the original equation. So if our original equation is x squared minus 5x plus 6, we would substitute 2.5 in for x, and we would find out what it would equal. And the answer, I'm going to spare you going through it all over again because this is not how we would solve this question, would be negative 0.25. So then we would plot out negative 0.25, which is roughly there. Our y-intercept is at 6. 1, 2, 3, 4, 5, 6 is right here. And then you would plot it. And then you'd be like, hey, what are the x-intercepts? And you would then get really angry because you're like, I didn't even need to do all that extra work. These are our x-intercepts. And you would be very right. Okay, so to graph this one manually by Xavier method is kind of not what you would do. You would solve this one with algebra, but I just wanted to go through the steps of how you would do it. You would not solve quadratic like this with Xavier method, because if you can factor it, you know the answer. So you should be, though, able to get a graph like this and be able to tell me, like, pretend we didn't get this equation, we just got this graph and it said what's the solution to this equation. You should be able to read off of it that, hey, the x-intercept here is at 2 and the other x-intercept here is at 3, so the solution is 2 and 3. You should be able to do that. And yes. So the next thing I want to just kind of briefly touch on is that you should also be able to determine how many solutions something has. So if you were given a graph like this, or maybe you graphed it using technology and it looked like this, the vertex is sitting on the x-intercept, which means there's only one solution. Okay. If you had something like this, you should be able to tell me how many solutions this one has. And it crosses the x-axis twice, so there are 2 solutions. You should also be able to tell me what the solutions are. So here the solution is at -3, and the other one happens here, or I meant for it to happen here. It's at 1, 2, 3, 4, 5, 6. It's at 6. And the solution here, let's just say the dot was right here conveniently on something, 1, 2, 3, 4, 5, 6, 7. So the solution here was 7. You can also have something that looks like this. This parabola does not cross the x-axis. Its minimum is above 0. So it will never cross the x-axis. So there is 0 solutions. So if you have a parabola that opens up and has a minimum value above 0, there is no solutions. If you have a parabola like this one that opens downwards and has a maximum value below 0, you will also have no solutions. There's going to be no x-intercept. Okay. So when you're going to use graphing to solve is when you're going to get a trinomial that does not factor nicely. So like the one I just did before, graphing it was kind of redundant and not really necessary because you already had the answer really quickly in order to graph it with Xavier's method, or you could just solve it algebraically and not even graph it at all. But if you look at A, B, and if you look at, sorry, I just realized I had a moment here. If you look at this A, this B, and this B, and you tried to factor them, you would not be able to. And this is when we use either technology to graph it for us, Or you use something called the quadratic formula to solve it algebraically. Because this is how to learn it solved by graphing, we're going to solve it by graphing. So to do this, you are going to use that TI-83. Now you could use Desmos as well. Desmos is really nice. I love it. You put the equation in, it doesn't care whether it's a negative or a minus, and then you just hit the dots and it magically just tells you what the points are. That's lovely. However, you can't use that when you are in an assessment in Pre-Calc 11 or normally in an actual physical classroom in Pre-Calc 11 or in Pre-Calc 12. So you need to get used to using this lovely thing. So the first thing you're going to do is you're going to enter that equation again, and I went over how to do this in a previous video, so I'm just going to quickly go through, enter my equation. I'm going to graph it to make sure my window is appropriate. Now, when I'm trying to find the roots, I don't need to see the vertex. And I don't need to see the y-intercept either, because I'm not looking for that information. All I want is the values of those x-intercepts. So I'm going to go second function trace. I'm not going to adjust the window. I'm going to go to zeros because this is graphed as a function, not a equation, even though it is an equation. We're going to find the zeros, which are going to be our roots. And it's going to do that left bound, right bound stuff. So I'm going to go left bound here, hit enter, right bound here, hit enter, tell it to guess, hit enter. And it told me the first one is at negative 1.216991. So I would write that down as my first answer. And then I'm going to do the same thing to find my second one. So I'm going to go, I'm not even going to worry about clearing my screen. I'm just going to go right to second function trace again to get that calculate menu again. I'm going to hit number 2. Again, and this time I'm going to go wee all the way down and around. Sound effects make it better. There we go. Eventually it comes back around. Here's my left bound. Here's my right bound. We'll hit enter for guess. And there it goes. It tells me my second one is at 8.2169906. So the downfall of using a technology like a graphing calculator to solve for x-intercepts when they are not nicely factored trinomials, you're going to get answers that are rounded off. Anytime you use a calculator to calculate, you're going to get a truncated answer, which means that you're going to lose precision. All right, so if we go back to our notes, I'm just going to record those values that we got for this first one. So we got x equals negative 1.217, and we got also 8.217, and I rounded off to 3 decimal places. If you're in the middle of your calculations, you want to either keep the exact value using radicals, which we're going to practice with the quadratic formula, or you're going to keep as many decimals as possible, right? The second one here, you can actually factor that one. So x is going to be negative 2 and 6. Okay, but you can also put that in your graphing calculator and verify that that's the answer. Okay, I want you to pause the video here and get these answers on your graphing calculator. I'm not going to go through and put you through the pain of watching me do this on a put this on a graphing calculator that's on my computer screen. It's a little bit tedious. All right, so you should get that for the, I guess, I don't know, the second B. I was really feeling B's in this moment. And in the last one, you should get negative 3.646 and 1.646. Okay, so hopefully that's what you got. If you're having problems using your TI-83, please let me know and we can troubleshoot together. I know that Desmos is an easier program to use. However, I caution you from just using that to get the answers done quickly, because in the long run, you still need to use the TI-83 in class. And so you need to practice that skill. If you're not intending to take Pre-Calc 12, then maybe go ahead and start using Desmos. The last thing I want to mention is when you have an equation that looks like A and B here. So if the equation doesn't equal 0, you're going to use algebra to move all the terms to one side so that one side does equal 0, because then you can graph it as if it was a function and find the zeros of the function, because those zeros are your roots. Okay, so for this one here, you're just going to add 2 to both sides. And you're going to rewrite it out using your term with the biggest degree for the variable first. And then there you go. Now, if you can factor that, you would factor that, but you're not going to find two numbers that multiply to 2 and add to -7. So you're going to go, ooh, I can't do that with Xavier's method. I can't do that by algebra. I'm going to graph and find my answers by finding the x-intercepts. And you're going to find that x equals 0.298 and 6.708. So again, I'm saving you watching me put this in my graphing calculator and doing left bound, right bound guess all over again, twice for each one of these. But I would like you to pause the video, try these, and then see if you get the answers right. Okay. So the next one here, you would need to subtract 5x from both sides. So this would become x squared minus 15x equals 23. And then you can subtract 23 from both sides as well. And you're going to get x squared minus 15x minus 23 equals 0. I know some of you are going to be like, can I just do it both things in one step? Yes, you can. I'm just doing it in 2 steps to show it. And then you're going to plug this into your graphing calculator and you are going to solve. And you should get x equals negative 1.402. That does not look very legible. Let's fix that one up for you guys there. Negative 1.402 and 16.402. Now I'm rounding these off to 3 decimal points, and that's really important to remember because I should be able to put, for instance, this value in here for x here, and x here, and simplify both my left and right side, and I should get my left side equaling my right side. However, because I am rounding off to 3 decimal places, there is some precision lost. So if one side was like 15.06 and one side was 15.02, that's where that discrepancy comes from, and I don't need to worry about it. Now, if I was off by quite a lot, then I would have to kind of look back and see, did I mess up somewhere? I would like you guys to try those questions. And I'd like you guys to try using your TI 83s, especially if you're going on to Pre-Calc 12, where you're going to need to be able to use your graphing calculator. I hope you enjoyed this lesson or understood it. If you have any questions, please let me know. I hope you guys are all doing well. Take care, all the best, and goodbye.